Good evening. So do you have any doubt from last class?
No, sir.
Yes, sir.
Yes, ask.
A clock with an iron pendulum keeps correct time at 20 degrees Celsius. How much will it lose or gain if temperature changes to 40 degrees Celsius? Coefficient of cubical expansion of iron is equals to 36 into 10 raised to 60. Yes, sir.
In the application of linear expansion, I defined you how the reading of clock will change on increasing decreasing temperature. So the formula was delta T equals to half alpha T naught times delta T. So we have alpha in this part. Let's say this particular T naught to be 1 second or unit T, for which you have to calculate. Delta T is change in temperature. So half, tell me the value of alpha, or in this question you have given gamma. So Myra,
36 into 10 raised to minus 60.
it should be -6 only.
Hmm.
So you can solve alpha equals to gamma by 3. So it will be 36 divided by 3 into 10 to the power -6. So you'll get 1 in 10 to the power -6. It will be 3.6. Okay. Now we have alpha, take T naught to be 1 second to be unity, and you have temperature difference. So alpha is 1.2 into 10 to the power -6. T naught is 1 second. And delta T is temperature difference. So Myra,
20 degrees.
okay. You can simplify it to get time difference or time change by that particular clock in 1 second.
Okay,
Okay.
sir.
Any more doubt?
No, sir.
I think this question is from assignment.
Yes, sir.
And I haven't got any assignment of this particular part yet. Last, I got Bernoulli's principle. Okay. So this is all about expansion of solid on heat or heating effect of expansion. Next term is calorimetry. Calorimetry is simply exchange of heat between body or system, which results in change of their temperature or change of their state, is called calorimetry. Suppose if you drop ice in hot water, so the temperature of water will decrease and state of ice will change from ice to water, then its temperature will rise to acquire some equilibrium temperature. So you'll say there is exchange of heat between two different systems. One is hot water and other is ice. First to change the state of ice and then to change its temperature. So these type of interaction is defined by calorimetry. So calorimetry is the study of exchange of heat between body or system which results in change in temperature or change in their state. It is based on conservation of energy So using conservation of energy, we may define principle of calorimetry. It says if two different bodies are interacting, so one should lose some amount of heat and the other should gain that much amount of heat. So heat lost by one body must equals to heat gained by another body. Aisha, is it clear?
Yes, sir.
Okay. Now, on the basis of this particular interaction, which results in change in their temperature or change in their state, we may define different terms. First, heat, which causes to change their temperature. And the second, heat, which causes to change their state. So for first part, heat, which causes to change their temperature, we may define three different terms. First is heat capacity. Second is specific heat capacity. And third is molar specific heat capacity. Second part, heat, which causes to change their state, may define first latent heat of fusion. And second is latent heat of vaporization. Okay, first write it down, then I'm defining you the rest part.
Then, sir, can you scroll a little bit down? Done, sir. Done, sir.
Asma, done?
Yes, sir, done.
Sakshi, you have written?
Yes, sir.
Okay. Now the first part is heat capacity. You must have learned some of these terms in your earlier classes in class 7th or 9th, but only definition part. Let me define you first. Heat capacity. It states the amount of heat required to raise the temperature of any substance by 1 degree Celsius or 1 Kelvin. So it is the amount of heat is required to raise the temperature of substance by 1 Kelvin or 1 degree Celsius at normal atmospheric pressure. So Q equals to S, that is heat capacity, times change in temperature. So this S is called heat capacity constant. So its SI unit related to this formula will be Joule per Kelvin. Aisha, any doubt?
No, sir.
Okay. Suppose if you define some mass related to this particular heat, we call it as specific heat capacity or specific heat constant. Specific is for fixed amount of mass of that particular substance. So it is the amount of heat is required to change temperature of 1 kg substance by 1 Kelvin or 1 degree centigrade at normal atmospheric pressure. So Q equals to mass of substance times specific heat constant times delta T. So this small s is called specific heat constant. Specific heat constant or capacity. So its SI unit will be Joule per kg per Kelvin. You have to memorize some of the values related to some term. First, the specific heat capacity for ice and specific capacity for vapor. It will be 0.5 calorie per gram per Kelvin, and specific capacity of water, which is maximum 1 calorie per gram per Kelvin. Now in this part, I have written in terms of calorie and gram, which is easy to learn. If you have to convert it into SI unit, 1 calorie equals to 4.186 joule, or you may write it as 4.2 joule. Samaira, is it clear?
Yes.
Okay, first write it down till this part.
Done, sir. Done, sir. Done, sir.
Asma, done?
No, sir.
Okay. Sakshi, you have written? Okay. Asma, done?
Yes, sir, done.
Okay. In this part, I've defined to take mass of substance as 1 kg or amount of substance in terms of kg. Similarly, we may define next part, molar specific heat constant or capacity. It is mainly defined for gases in which amount of substance to be 1 mole. So the amount of heat is required to change 1 mole of gas, change temperature of 1 mole of gas by 1 Kelvin or 1 degree centigrade at given condition. I will define you in thermodynamics about the various conditions on which this molar specific heat constant may depend upon. So Q equals to NC times delta T. So this C is called molar specific heat constant or capacity. Since in thermodynamics, we may have different processes, isothermal, isobaric, isochoric, adiabatic. So on the basis of different process, this C or molar specific constant may change its value. That's why I've written at different condition, it will have different values. Samaira, is it clear?
Yes, sir.
So these 3 heats basically to define change in temperature of those substances. Next is latent heat of fusion. It is amount of heat to change solid into liquid at its melting point and normal given condition. So the amount of heat is required to change 1 kg solid into liquid at its melting point and normal atmospheric pressure. So Q equals to mass of substance times latent heat of fusion constant. So this L is called latent heat of fusion constant. For ice, it is equals to 80 calorie per gram. Similarly, we may define conversion of liquid into vapor, which is called latent heat of vaporization. So next is latent heat of vaporization. The amount of heat required to change 1 kg liquid into vapor at its boiling point and normal atmospheric pressure. So Q equals to mass of substance times latent heat of vaporization constant. So this LV is called latent heat of vaporization constant. And for vapor, it is equals to 540 calorie per gram. Just write it down to this part.
Answer, can you please scroll it down? Done, sir. Done, sir.
Yes. Asma, done?
No, sir.
Okay. Asma, done?
Yes, sir, done.
Okay. So to define this whole different term, let me define your graph. Let's say this is temperature versus heat. Consider ice to be initially at some low temperature minus 10 degrees Celsius. So on heating, temperature of ice will change from minus 10 degrees Celsius to reach at 0 degrees Celsius. So this heat, which causes to change its temperature, is termed as specific heat. Now, and further, at this point, it will be in ice. On further heating, it will change state like this into water. This heat, which causes to change its state, is called latent heat of fusion. On further heating, it will change its temperature to reach at this point 100 degrees Celsius. State will remain water. This particular heat is causes to change its temperature, so we termed it as specific heat. On further heating, there will be change in state from water to vapor till this point. which is termed as latent heat of fusion. On further heating, temperature of vapor will start increasing like this. So it will be termed as a specific heat. Now just see in this particular graph, for two different points when state is changing. First at this point, ice to water, and at this point, water to vapor. You'll observe there is no change in temperature. So question is, why there is no temperature in there is no change in temperature on changing state? You must have learned this particular concept in class 9th. Sakshi, would you like to define why there is no change in temperature or changing state? Asma, any idea? Samaira?
Don't know, sir.
So I guess I know, but I'm not sure about my answer. Is it due to the latent heat? Like when the heat is supplied to increase the temperature of substance?
Just see this particular graph. There is no change in temperature. That's why I have asked why there is no change in temperature. You'll say on giving heat to this particular ice or water to change its state, the total amount of heat supplied to the system is utilized in breaking of bond so that to change its state from one form to another, so that there will no change in temperature. Is it clear?
Yes, sir.
That's why it is called latent or hidden heat, since there is no significant change in temperature. So you'll say during change of state, heat supplied to the system is utilized in breaking of bond. So there is no change in temperature till complete conversion or whole complete conversion of state. Samaira, is it clear?
Yes, sir.
Okay, the next question is, which will cause more severe burn, boiling water or steam at same temperature? Sakshi, any idea? Which will cause more severe burn, boiling water or vapor at same temperature? Let me define using this particular graph. Good, Sakshi. Just draw a vertical line at this point and a vertical line at this point. Now, if I ask you, which of these two substances having more amount of heat, vapor or water?
Vapor.
Good. So you'll say at same temperature, vapor will have large amount of heat as compared to water. So it can cause more severe burn. Okay. Asma, any doubt? Aisha, is it clear?
Yes, sir.
Okay, similarly, at this point, if question is which one will cause or which one will be more effective in cooling, ice or water at same temperature? Samira?
Ice.
Good. So you will say, since ice having more amount of cold energy as compared to water at same temperature, so ice will cause more effective in cooling, or ice will be more effective in cooling as compared to water at same temperature. So on the basis of this graph, we may define heat or cold energy related to these two substances. So first is at same temperature, 100 degrees Celsius, vapor having more heat energy as compared to water. So it can cause more severe burn. Next, at same temperature, 0 degrees Celsius, ice having more cold energy or less heat energy as compared to water. So it will cause, or it will be more effective in cooling. Okay, just write it down. First, draw this graph. Just 1 minute, I'm coming.
Done, sir.
Done, sir.
Asma, you have done?
Yes, sir, I've done.
Okay, Sakshi. Okay, now let me give you some problems related to this part. If 10-gram ice at 0 degrees Celsius, find first heat required to convert it into water at 10 degrees Celsius. Next, how much water at 100 degrees Celsius is required to supply heat equals to above part. Let me define you how to simplify it. First, draw the graph related to this whole process. This is Q versus temperature. Initially, we have ice at 0 degrees Celsius. At this point, let's say A. So first it will convert into water to reach at this point B. This amount of heat, let's say Q1, must be to change state from ice to water. So this will be termed as latent heat of fusion. On further, it will start to change its temperature to reach at this point, 10 degrees Celsius. So this heat will be Q2. Let's say point C. So first try to find the value of Q1 and Q2. Try to solve. Using above formula, Q1 is latent heat of fusion. So it will be mass of ice times latent heat of fusion constant of ice. Q2 is specific heat to convert its temperature from 0 degrees Celsius to 10 degrees Celsius. So it will be mass of ice that has converted into water, a specific capacity of water, change in temperature, it will be 10 minus 0. Just put the values and simplify it. Try to solve. Good, Samara. Try to find the second part. Sakshi, you got any answer? Asma? Let's see. We have mass of ice given in this question 10 gram. Latent of fusion constant for ice is 80. So on multiplying, you will get 800 calorie total amount of heat required to convert ice into water. Aisha, is it clear?
Yes, sir.
The next part, to change in its temperature from 0 degrees Celsius to 10 degrees Celsius, mass of ice 10, specific heat capacity of water is 1, and temperature changes 10. So on multiplying, you will get 10 to 10, 100 calorie. So in total, if you add these two terms, Q1 plus Q2 equals to 800 plus 100 equals to 900 calorie it would require to change state or to further convert its temperature from 0 degrees Celsius to 10 degrees Celsius. Sakshi, any doubt? Asma, is it clear?
Yes, sir, clear.
Okay. Now the second part is this much amount of heat must be supplied by water which is initially present at 100 degrees Celsius. So you will say we have water at this point 100 degrees Celsius. It will decrease its temperature to reach at this end, and during this process it will lose some amount of energy Q2 which must be equal to total amount of heat required by ice to change its state or further convert its temperature to 10 degrees Celsius. So we have to calculate how much of mass would require to perform this process. So for the second part, Q2 equals to mass of water, specific heat capacity of water, and change in temperature is 100 minus 0. Initially, it is at 100 degrees Celsius, and finally, it will reach to 10 degrees Celsius for equilibrium. So if this Q2 is given, a specific heat capacity of water is also given, you have to calculate mass of water required. So it will be 900 mass of water times 100 minus 10, it will be 90. So on solving, you will guess mass of water equals to 900 divided by 90, that is 10 gram. So for this process, we need 10 gram of water to change this particular conversion of ice. Samira, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
You all have written?
Yes, sir.
Nahara?
Yes, sir.
You have written?
Yes, sir.
Okay. Find amount of heat is required to change 20 gram ice at minus 10 degrees Celsius to water at 40 degrees Celsius. First, plot the graph related to this conversion and try to find. Specific capacity of ice is 0.5 calorie per gram. Specific capacity of water is 1 calorie per gram. And latent of fusion of ice is 80 calorie per gram. It should be per Kelvin per Kelvin. So Myra, just tell me how to calculate this part. First, we have ice at minus 10 degrees Celsius. So it will be at this point. So on heating, how will it change?
It will
Initially, first on heating, it will change its temperature from minus 10 degrees Celsius to 0 degrees Celsius. Okay. So this will be termed as specific heat, which may be calculated as mass of ice, specific capacity of ice, and change in temperature 0 to 10. So it will be just 10 degrees Celsius. Further, on heating, it will change its state from ice to water. Let's say this is Q2. So this must be equals to latent heat of fusion, mass of ice, latent heat of fusion constant. On further heating to reach at 40 degrees Celsius, it will be termed as specific heat, Q3, mass of ice. Now it has converted into water. So it will specific heat of capacity of water and change in temperature 40 minus 0. Put the value of each term and simplify these three terms, add them together. Samira, is it clear?
Yes, sir.
Okay, try to solve. We have mass of ice to be 20 gram and these known values. Myra, just send me your answer. Asma? Since you have calculated in terms of calories, so it should be in terms of calorie, okay?
Okay, sir.
Aisha, you have solved?
No, sir, solving.
Okay. Just send me individual part for Q1, Q2. Asma, you have solved? Just see, for Q1 equals to mass of ice, a specific capacity of ice, and change in temperature. So it will be just 10. Mass of ice we have given 20 gram. Specific capacity of ice is 0.5 multiplied by 10. So 20 into 5, it will be 100. So Q1 will be 100 calorie. Similarly, Q2, which is to change its state. So it will be mass of ice times latent fusion constant. Mass of ice is 20 gram and latent fusion constant is 880. So 8 into 2 is 1600 calorie. And third part, to raise its temperature from 0 degrees Celsius to 40 degrees Celsius. So mass times specific heat capacity of water times change its temperature. So it will be 20 into 1 into 40, 8 into 2, 4 into 2, 800 calorie. So in total, if you add these terms to get total amount of heat required for this particular whole conversion is 100, 1600, 1700 plus 800, 2500 calorie. Nahara, is it clear?
Yes, sir.
Okay. You all have written? Sakshi, any doubt? Okay. Asma, done? So this is all about calorimetry or exchange of heat between bodies or system, which results in temperature change or state change. Next is transfer of heat or heat transfer. In this, first process is conduction. Next is convection, which is deleted from your course. And third is radiation. So let's start with first part, conduction. Suppose there is a rod in which initially particles are arranged in their perfect manner like this. So what will happen if you increase temperature of any particular end, let's say at this end, on increasing temperature. So on increasing temperature, according to the concept of thermal kinetic energy, you will say kinetic energy of particle increases. On increasing kinetic energy, they will vibrate to some larger distance. Initially, these particles are vibrating up to this small distance. Now, on increasing temperature, vibrational energy of particle increases. So they will vibrate to some larger distance. As a result, they will collide with its neighboring particle, during which or during collision, some of their energy may get transferred from one molecule to the another particle. This process will continue till flow of heat from one end to the other end. So this is called process of conduction or heat transfer through conduction. Asma, is it clear? Samaira?
Yes, sir, clear.
Okay. So you'll say on increasing temperature, thermal energy of particle increases. So they can vibrate to longer distance. As a result, get collided with neighboring particle. During which some of their energy got transferred. This process will continue till heat or energy reach to other end. Sakshi, is it clear? Let's write it down.
Done, sir.
Nahara, you have written?
Yes, sir.
Asma, done? Now, to define this particular process, let me define you concept of electricity. You must have learned in class 10th. Electric current. Next is heat current. Samara, just tell me, what do you mean by current? Is it rate of flow of charge or something else?
Rate of flow of charge.
So how it would be heat current?
Rate of flow of heat.
So what do you mean by current then? Current means simply flow of any quantity, whether it is electric charge, so it will be called as electric current, whether it is flow of heat, so it is called heat current, flow of air, so it is called air current, flow of water, water current. Flow of anything through any particular substance is called current. Okay?
Okay, sir.
Suppose we have a conductor having length L, area of cross section A. So if you have to flow charge through this particular conductor, what you need? You must need some potential difference across the end, which causes flow of charge through it. So let's say this end is at some voltage V1, this end at some voltage V2. So first we define potential difference, which is responsible for flow of charge through any particular conductor. Sakshi, is it clear? Similarly, let's say you have a conductor and through which we have to conduct heat. So you must need temperature difference across its end. So this end at temperature T1, this end at temperature T2. Length of this conductor is L and area of cross section at this end is A. So you must need temperature difference for the flow of heat through this particular substance. So delta T equals to T1 minus T2. Nara, is it clear?
Yes, sir.
Okay. So you can compare between these two different things. For electric current, we must need some potential difference. And for flow of heat current through conductor, we must need temperature difference across it. Next is, through this particular conductor, if charge is flowing, there must be some opposition offered to the flow of charge through it, which is called resistance. So next we define a resistance or opposition caused in the flow of current through any conductor. which is equals to rho L by A. You must have learned about it. Rho is resistivity, L is length of conductor, A is area of cross section. So rho is resistivity. The reciprocal of this particular term is called conductivity, which is defined by sigma, which is equals to 1 by rho. So this sigma is called conductivity. Similarly, in terms of heat, we may define conductivity as K, thermal conductivity. So you may transform this formula in terms of conductivity as length divided by sigma into A. So Myra, is it clear?
Yes, sir.
Now, if you have to calculate resistance offered to the flow of heat current through this particular substance, we may define thermal resistance. So it should be equals to length of conductor divided by conductivity, which is K in terms of thermal, times area of cross section. Is it these two substances are similar to each other? Okay. Asma, any doubt? Now the next part is current. For electric current, we defined I, which is or simply electric current. Rate of flow of charge, which is also equals to charge flowing through any particular conductor divided by time taken equals to I. Similarly, in terms of heat, we may define heat current, which is represented by H. So it should be rate of flow of heat. Rate of flow of heat. So it should be amount of heat flowing, which is represented by Q, divided by time taken equals to H. Aisha, is it clear?
Yes, sir.
Okay. Now you must have learned about Ohm's law in class 10th. Samira, just define what do you mean by Ohm's law?
So can I say?
Samira, any idea?
Sir, I only know the equation.
Okay, just tell me.
I is equals to RV.
I is equals to RV or something else. Okay, no problem. Nara, do you have any idea what do you mean by Ohm's law? You must have learned a whole chapter electricity in class 10th.
So can I say?
Yes, sir.
Yes. Just 1 minute. Nara? Okay, Aisha, you can explain.
Ohm's law states the current flowing through the conductor. It is directly proportional to the potential difference applied across its end.
Good. So potential difference applied across the end of a particular conductor is directly proportional to amount of current flowing through it. So on rearranging, you will get potential difference equals to current times resistance offered by this particular substance. Since we have to calculate current, so we can write I equals to potential difference divided by resistance. On putting the values of each term, you will get delta V, resistance is L by sigma into A, So L divided by sigma into A. Current is nothing but flow of charge through conductor per unit time. So you'll get this much amount of expression. Similarly, for heat, we may define Ohm's law. So for this heat current, we may define H equals to amount of potential difference. In terms of heat, it is termed as temperature difference divided by thermal resistance offered by this substance. So on rearranging, you will get Ka times delta T divided by L. Heat current is nothing but flow of heat through conductor per unit time. Samaira, any doubt?
No, sir.
So just relate these two substances or these two different quantity so that it will be easier for you to learn this. Nahara, any doubt?
No, sir.
Okay, just write it down.
Answer.
Done, sir.
Asma, you have done?
Yes, sir, done.
Okay. Sakshi? Now let me give you a question related to this part. Before that, let me define you how to calculate resistance related to any particular rod. Concept of resistance or calculation of resistance. Suppose you have having this as X, this as Y, Z. Now suppose if current is flowing across this end, So what will be resistance offered by this particular conductor in this part? So let me define you. Resistance equals to 1 by sigma length divided by area of cross section. For any term, length should be always parallel to the flow of current, and area of cross section should be perpendicular to the flow of current. So in this part, which dimension is parallel to the flow of current? Samira? Current is going along this way. So which of the dimension in these three terms, X, Y, Z, is parallel to the flow of current?
X. Z. Z.
Okay. And which dimension or which area is perpendicular to the flow of current? So you'll say this part, whose area will be product of X and Y. So for this part, we may find resistance equals to Z divided by sigma times X into Y. Is it clear? Aisha, any doubt?
Not sure.
Okay. Nahara, is it clear?
Yes, sir.
Okay. Just write it down. There is a rod having dimension 50 centimeter, 20 centimeter, 20 centimeter, thermal conductivity 0.8 watt per meter Kelvin, whose one face is connected to furnace at 100 degrees Celsius. The other is connected with ice at 0 degrees Celsius. Now for this part, you have to calculate, find first temperature difference, next temperature gradient, third thermal resistance, since in this part heat will flow from higher temperature to lower temperature, so it should be along this direction. So the dimension which is parallel to this direction of flow is 50 centimeters. So take 50 centimeter as length. And this cross-sectional area will be taken as area of cross-section. Now try to find these three terms. Just send me the answer related to this part if you have solved. Nara, what do you mean by temperature gradient? Or simply, what do you mean by gradient? Aisha, any idea what do you mean by gradient?
So you're asking gradient or temperature gradient?
Just first define gradient and then temperature gradient.
Gradient. It's
Okay, temperature gradient.
It's a physical quantity that describes in which direction and the rate temperature changes most rapidly.
Okay, Samaira. I defined you in fluid part. Let me show you. What is written? Gradient is change of any quantity with respect to length. Okay. Since in this part, we have to calculate temperature gradient. It means change in temperature with respect to length. Okay. Aisha, is it clear?
Yes, sir. Yes, sir.
Okay. Samara, how much you have solved? First, second.
Sir, only first one.
Temperature difference, that is delta. It means higher temperature minus lower temperature. Temperature gradient is temperature divided by its length. Thermal resistance, length divided by thermal conductivity into area of cross section. Try to find these three terms first. Let me solve. First is temperature difference, higher temperature minus lower temperature, so it should be 100. Second is temperature gradient, that is temperature divided by length. Length is 50 centimeter. You may write it in terms of meter as 0.5. So it will become 200 degrees Celsius per meter. For third part, thermal resistance, length is 0.5, thermal conductivity is 0.8, area of cross section 0.2 into 0.2. So you'll get 5 divided by 8 into 4, 2, 32. On solving, you'll get 15.625 Kelvin per watt. Samara, you got this answer or something else? Asma? You got this or something else? Good. Similarly, we may find heat current, H equals to temperature difference divided by thermal resistance. We have temperature difference as 100 and thermal resistance as 15.625. So 100 divided by 15.625. On solving, you'll get 15,690. So it will be around 6.4 watt. And for last part, if you have to calculate how much heat will reach to the other end, that is H is equals to Q divided by T. So Q will equals to H into T. 6.4, time taken is 1 minute, or it will be 60 seconds. 6 into 4, 24, 6 into 6, 36, plus 2, 38. About this much. Nahara, any doubt in this whole calculation?
No, sir.
Okay. Just write it down. You all have done till this part?
Yes, sir.
Sakshi, any doubt? Nahara, you have written?
Yes, sir.
Okay. So let's stop here for today. In next class, I will define you combination of rod, since you have learned about series combination or parallel combination of resistance in your class 10. Similarly, we have to calculate combination of rod for series as well as parallel combination. Okay?
Okay, sir. Thank you.
Okay then, thank you.
Bye, sir.
Thank you.